when you're ready.
Yep, ready.
So today I'm going to talk about the Cynefin Framework, Cynefin. It's a Welsh word. It means habitat or place. And the guy to Google is called David Snowden, who's a really smart academic. And if you go on YouTube, he's got really good explanations of Cynefin. But this is my interpretation of it. It's a sense-making tool, so although it looks like there's an X and Y matrix here, this is not just an X-Y matrix. What we're saying is in the world we have order, we have disorder, but we also have unorder. But when we're in the ordered state, we can group into something being a domain of either simple, complicated, complex, or chaos. Now, first thing this morning, who can remember that exercise we did? What was the first exercise?
Tallest to shortest.
Tallest to shortest, right? And I said you got 10 or 20 seconds, organise yourself, and it was dead easy. You could have done it in silence. In fact, I think you just did, just sort of eyed each other up. That was the first one, that was simple, okay? In a simple domain, there is a best practice. There are known knowns. So we'll put best practice here. Now, think of a factory. In a factory, what you want to do is reduce the variation on the number of widgets. You know with an input, there's a known output. And we use techniques such as Lean Six Sigma to control that variation, which is a statistical process control. We have a best practice. What we do is we sense, we categorize, and we respond. Because there's a limited number of inputs and outputs, and there are known knowns, there's always known cause and effect. So think of the game noughts and crosses, or tic-tac-toe. There's a limited number way of playing, it's dead easy, everyone understands it. And if you're the first player, there's a way to guarantee that you will not lose. There's no way of guaranteeing that you'll win, but it's very simple and very easy to understand. So this is in the simple domain. And think of that first exercise we had. I didn't really have to explain how to do it, you just went away and did it automatically, dead easy. So this is simple, and a lot of the work we used to do in automated, which is now automated, was in the simple domain. Next I'm going to move over to complicated. And the example I've got here is building a bridge. So if you were to get a load of civil engineers together and ask them how to build a bridge, you may have multiple different solutions. And that's because there isn't a single best practice, there's a good practice. So there's lots of known knowns, but there's lots of unknown unknowns as well. So they know the tensile strength of steel and concrete and how to design a bridge. But what they don't know is what's in the base of the river. Is it granite or is it sand? So they need to do analysis. So here, what we do is we sense, we analyze, and we respond. And it's fair to say the more analysis you do, the greater the chance of success. So you can mitigate risk by more analysis. This is industrial thinking. This is waterfall. This is what we've been doing since the Industrial Revolution for 150 years. There's a good practice. There's known unknowns. We sense, we analyze, and we respond. The second exercise you did, can you remember that? How did the second exercise go?
Ran each other by size and age.
Size and age. And somebody said, well, why don't we put ourselves in two axes? And in the end, you worked it out. It needed a bit of feedback, and it took a few minutes. But in the end, you worked it out. It was straightforward enough. But you needed to collaborate. You needed to ask questions, and the answer wasn't obvious. So here, we sense, we analyze, we respond. The game I would like to compare this to is chess. So in chess, there is almost an infinite number of ways of playing chess. I think it's 1 times 10 to 120. So more chess moves than there are stars in the universe. It's huge. But it is possible to analyze a solution. So a computer has beaten a human. Deep Blue beat Gary Kasparov about 20 years ago. So here, the more analysis that you do, the more chance of success. And it's good practice. And there's known unknowns. This is great for sequential planning and waterfall processes. Third domain is complex. In complex, we have an emergent practice. This is because we've got to learn from feedback. We'd have a hypothesis, we would test that hypothesis, and at the end we'd either amplify or dampen based on the feedback. So I've got here a picture of an iPhone, and we've maybe got software as a service. The only way you know if it's going to be impactful for the customer is to provide the customer with a minimum viable product and see how they respond and get the feedback. So this is different here. Doing more and more analysis isn't going to give you the answer. The answer lies within the customer. So here we probe, we sense, and we respond. The difference here is we probe before we sense. Here we sense first in these two. So this is complex. In complicated, we have known unknowns. Here we have unknown unknowns. There's things we don't know that we don't know. And the only way to find out is to get that feedback from the customer. The game here is poker. So, did I play poker here? So when playing poker, there's no way you can know what your opposing players have got, but what you can do is test them and sense how they play and make assumptions and then test those assumptions and continually play. So if you have a small batch size here and you're testing, that's the best way. You get a hypothesis and you can test it. So good practice, emerging practice, we probe, we sense, we respond here. I would suggest the work we do in the conceptual age is somewhere between complex and complicated, maybe with a bit of simple mixed in here. The reason I present this to you is because my suggestion is that in the complex world, agile practices lend themselves to having those small batch size hypotheses, tests, experiments that we test. Finally, chaos. I won't talk too much about chaos, just to say that you act, you sense, and you respond, and there's a novel practice. The interesting thing is, if you're in the complicated or complex domain, and you apply simple techniques, you can tend to fall off the cliff into the chaotic domain. So there we have it, simple, complicated, and complex, and chaos. And generally, what we're working with in IT and in the knowledge world is somewhere up here. Okay? Thank you.